Okay, before we start ray diagram, we need to make ourselves familiar with certain rules which we will follow while drawing ray diagram, right? So, this is concave spherical mirror. Its reflecting surface is towards the center of the hollow sphere of which it forms a part, and line joining PC, that's known as the principal axis. This is a convex spherical mirror. Its reflecting surface is away from the center of the hollow sphere of which it forms a part. Line joining P and C, that's the principal axis. Now, first rule, we have discussed the midpoint of P and C is the focus. Now let's concentrate on the first rule. A ray which is parallel to the principal axis, after reflection, it tends to pass through the focus in the case of concave mirror. And in the case of convex mirror, ray parallel to the principal axis will appear as if it is coming from the focus. The point to be noted over here is any line which is drawn behind the mirror, it's actually imaginary. So it has to be represented by dotted lines. So rule number 1, incident ray parallel to the principal axis, after reflection in case of concave mirror will pass through the focus, and in case of convex mirror it will appear to be coming from the focus. So that's the first rule. Second, again let's draw the diagram. This is the concave mirror. It's a part of a hollow sphere whose center is somewhere over here. The midpoint between P and C is F. Second rule is an incident ray which passes through the focus. After reflection, it will become parallel to the principal axis. Incident ray which passes through the focus. After reflection, it will become parallel to the principal axis. This is rule number 2. So this is the diagram for concave mirror. Convex mirror, same rule. Let's apply the same rule. So this is the convex mirror. Its center of curvature will be somewhere over here. Reflecting surface is away from the center. This is the pole. Line joining P and C is the principal axis. Midpoint of P and C is the focus. Now what I have stated is ray which is passing or which appears to pass through the focus, after reflection it will become parallel to the principal axis. This is the rule. Here focus is the virtual, which is behind the mirror. So this is the incident ray which tends to pass through the focus. But before it reaches the focus, it will get reflected, and that reflected ray becomes parallel to the principal axis. So this is rule number 2, right? So second rule is incident ray passing through the focus. After reflection, it becomes parallel to the principal axis. Third rule. Concentrate on this particular diagram again. Let's draw the diagram. This is the pole. It's a part of a sphere, the center of which is the center of curvature, and this is the principal axis. This is the focus, exactly the midpoint between P and C. Now, any ray which is incident on the pole, as you are aware, this axis it will act as a normal. So this will be the angle of incidence. It will bounce back into the same medium like this. So incident ray which is incident at the pole, it will bounce back into the same medium obeying the laws of reflection. This is the angle of incidence and this will be the angle of reflection. Let's draw the same diagram in case of convex mirror. Well, this is the convex mirror, this is the pole, this will be the center of curvature, line joining P and C, that's the principal axis, and the central point, that is the focus. So let's apply the same rule in case of convex mirror. Ray incident at the pole, this will act as a normal, so this will be the angle of incidence. It will bounce back into the same medium. So it will bounce back into the same medium. So this is the reflected ray and this is the angle of reflection. So the ray of light which get incident at the pole, it will bounce back into the same medium, obviously obeying the laws of reflection. So these are the 3 rules. There is a 4th rule as well, and you need to ensure whenever the reflected rays meet at a point, then at that point the image is formed. So let's discuss the 4th one. Okay, this is the 4th rule which we are going to discuss. This is the pole. It's a part of a sphere, the center of which is known as the center of curvature. The midpoint of P and C is known as the focus. Okay, we are aware if the angle of incidence is 0, then the angle of reflection is also 0. So for normal incidence, that is when the incident ray is parallel or coincident with the normal, then after reflection, the refracted ray tends to retrace its path in the opposite direction. So this is the very concept which we will be using over here. And you are also aware any line drawn from C that acts as a normal. So look, this is the incident ray passing through the center of curvature. So angle of incidence over here is 0. So after reflection, it will bounce back into the same medium, or it will retrace its path in the opposite direction. Here angle of incidence is 0, angle of reflection is also equal to 0. Point is, any line drawn from the center to a point on the surface of the mirror that acts as a normal. So here angle of incidence is 0, angle of reflection is also 0. Let's apply the same rule in case of a convex mirror. This is the pole, it's a part of a sphere, it's a part of a sphere. Look, this is a part of a sphere. Don't indicate this point as center of curvature. Make use of your common sense. It will be somewhere over here. This is the center of curvature. Line joining P and C is the principal axis. The midpoint of P and C is the principal focus. Now, ray which is passing through the center of curvature, in this case like this. To the extent it should meet point C. This is the incident ray. Then it should retrace its path in the opposite direction. So ray which passes through the center of curvature, after reflection it will retrace its path in the opposite direction, because here angle of incidence is 0, angle of reflection is also 0. So I'll repeat all the 4 rules. First one is, if incident ray is parallel to the principal axis, then after reflection it tends to pass through the focus. In case of concave mirror and in case of convex mirror, it appears to be coming from the focus. That's rule number 1. Rule number 2, incident ray which passes through the focus, after reflection it becomes parallel to the principal axis. Rule number 3, incident ray which gets incident at the pole, it will bounce back into the same medium, obeying the law of reflection. Fourth one is incident ray which passes through the center of curvature. After reflection, it retraces its path in the opposite direction. So these are the rules for the image formation. Once you are crystal clear about the rules, then you would not face any problem while drawing ray diagram for the formation of images when objects are placed at various positions in front of the mirror. Now what we do is, we will discuss new Cartesian sign convention. While using the mirror formulae and linear magnification, we make use of sign convention. Now look, and this sign convention which we are discussing, it's again valid for both the spherical mirrors, whether we are dealing with concave spherical mirror or convex spherical mirror. So it is new Cartesian sign convention. So this is concave mirror, this is the focus, this is the principal axis, and this is the convex mirror. And obviously in all the case, the object needs to be placed in front of the mirror. No point in placing the object behind the mirror. So object is to be placed in front of the mirror. This is the reflecting surface, here this is the reflecting surface. The object is to be placed somewhere over here. Right? This is supposed to be object. This is supposed to be object. Object is to be placed always in front of the mirror. Right? Now, first convention which we will be using is all the distances are to be measured from the pole of the mirror. Now, if you write the focal length of this concave mirror, so you should not write FP, this is wrong. You should write PF. If you want to measure radius of curvature, you shouldn't write CP, it should be PC. So what I mean to say is that P should be the initial letter. That is, all the distances, whether you are measuring the distance of this object, whether you are measuring the distance of principal focus, or whether you are measuring the distance of center of curvature, it should be always measured from the pole of the mirror. So P should be the initial point. Okay, this is the first convention which we'll be using. All the distances are to be measured from the pole of the mirror. Second rule. Now look, this is the direction of the incident ray. This is the direction of the incident ray. This is the direction of the incident ray. It is from left to right. So all the distances measured from the pole along the direction of the incident ray should be taken as positive, while distances measured from the pole against the direction of the incident ray, it should be assigned negative sign. So in this case, look, PF, you are aware its magnitude is F and PC, its magnitude is R. Now incident ray is starting from left to right, but PF, it is measured from right to left. That is in a direction opposite to that of the incident ray. So as per convention, it should be taken as negative. So it is minus F. Focal length of a concave mirror is always negative. Similarly, PC is the radius of curvature represented by capital R. Now PC, it is measured from P to C in a direction opposite to that of the incident ray. So it is to be taken as negative. Suppose this is the object AB. Now PB is the object distance. Again, all the distances are to be measured from the pole. P should be the initial level. So again, it is measured in a direction opposite to that of the incident ray. So it is negative. U. U denotes object distance. U is the notation which we will be using to represent the object distance. V will be the symbol or notation used to represent the image distance, all from the pole of the mirror. So remember, the focal length or the radius of curvature of a concave mirror or converging mirror is always negative. Let's use the sign convention over here. Over here, PF. Now look, incident ray is along this direction from left to right. PF is also measured along the same direction. So focal length is positive. This is the radius of curvature. Now PC. Again, PC is measured along the same direction as that of the incident ray. So it should be also assigned positive sign. Object distance. Suppose this is the object AB. PB. Now look, this is the direction of the incident ray and PB is measured in the direction opposite to that of the incident ray. So it should be taken as negative. So the second rule is all the distances measured from the pole of a mirror along the direction of the incident ray is to be assigned positive sign, while in a direction opposite to that of the incident ray is to be assigned negative sign. So one thing is very clear, the focal length or radius of curvature of a concave mirror or converging mirror is always negative. The focal length or the radius of curvature of a convex mirror is always positive. Right? Third rule is any distance measured perpendicular to the principal axis and in the upward direction, that is to be taken as positive. So for erect image, erect object, the size is to be taken as positive. While the distances measured perpendicular to the principal axis and in the downward direction, that is to be taken as negative. So in case the nature of the image obtained of this object is inverted, then it has to be assigned negative sign. You can make use of this, a simple quadrant system. This is positive, this is negative, this is positive and this is negative. This is the origin. Distance is measured along this direction, positive x direction is positive. Distance is measured from the pole towards the negative x direction, that is to be taken as negative. Distance is measured along the positive y-axis, that is for erect object or erect image, that is positive. Distance is measured towards the negative y-axis, that is for inverted image, that is to be taken as negative. So this is valid only when the object is placed in front of the mirror. That is, I have placed the object on the left side of the mirror.